Hey guys, how you doing? I just wanted to go and clear up everything from today with the workbook material. So just talking about what we did today. All right, just to reiterate everything. In 3.1, we learned our eyes aren't always the best judge of linear relationships, while correlation R gives us a better understanding of the strength and the direction. Remember, correlation is strength and direction. We still need to assess how well the least square regression line fits the observed data. So how is our actual values, how is that fitted, how is the actual values fitted by the least square regression line? Are there tight residuals or are there large residuals? We have to see. If it fits well, it may be a useful prediction tool. If it doesn't fit so well, we may want to search for a model that fits it better. One way to assess how well the least square regression line fits our data is to make a residual plot. Plotting the residuals gives us more information about the relationship between quantitative variables and helps us assess how well a linear model fits the data. If a residual plot shows a pattern, then a linear model is likely not appropriate. All right. And perhaps you should go to a nonlinear model. So for example, if we have a residual plot that looks like this, we would say, all right, that a linear model is not appropriate. All right. And you would have to go and, that's for a more advanced level, we would just, you would have to just try a quadratic model or something like that. All right. But right here, least square regression lines are only for linear. In this case right here, this particular residual plot right here, this is good. All right. A linear model is appropriate. So we would go try for a least square regression line. Okay. Lastly, we can also assess the fit of the least square regression line by interpreting the coefficient of determination, that is R squared. R squared is a measure of how well the regression model explains the response variable. Specifically, it is interpreted as the percentage of variation in the values of y that is explained by the least squared regression line of y on x. For example, R squared is 0.82. We can say that 82% of the variation in the response variable, whatever that is accounted for by the least square regression line. This says the linear relationship between y and x. Okay, you don't need to say the 18% part. So let's take a look right here. So we're looking at a residual plot right here, and I showed in class right here. You can do this right on the calculator right there. Okay, so let me show you right here. The one weird thing about the calculator, I'm going to erase this right here. We'll use a different color. It's black, that's fine. All right, so let's see here. Let's go and put the calculator side by side so we can just kind of see. So remember how I actually got to this part right here. So we went to stat, we went to edit. This was in the previous video. All this information is in L1 and L2. Okay, we put it all in. Okay, next right here. To go and graph this, you guys press second and stat plot. Okay, press enter right there. Go to that scatter plot right there, press enter, we got it. The X list is L1. Y list, to get RESID, residual. Okay, we have to press second. And right here on stat, there's this little list thing is where we want. So we're going to go in right there. And then under names, you see right there for 7, of course, it's RESID. So we're good, okay? All right, so we're going to go ahead and now go to zoom. And we want to go to zoom stat, which is number 9. There we go. Okay, we got it. All right, this part's annoying because when the trace doesn't go in order from left to right, which is what common sense would be, of course. So it goes in this weird order. All right, but it does actually go through, if you just go either the left or right button, it goes through all 10 of these points. These are 10 points here. So first we have 23, -2. So notice I already put the plot right here. The X values we just knew already were from 0 to 24. The residuals, I just looked right here. And when I looked at the residuals, it looked like when I got to the lowest point right there, it was -13.3. So I did -14 there. And the highest point was about right there, 5.6. Looks like the highest point, and maybe something about tiny bit higher. So I went up to 6. That should be fine. Okay, so let's do it right here. All right, so first we're going to go to 0, 5.6, and we're starting on this one right here. So 0, 5.6. Okay, that's about right there. Next, we're going to go to, move this over, there we go. Next one, just go right. Okay, 7, negative 13.3. Over 7, negative, there we go. Okay, then we have right here 20, 3.47, so that's rounded to 3.5. So over 20 up 3.5 is about right here. Again, you know, we're just approximating. Okay, then we have 20 and then negative 2.5. So over 20 down negative 2.5, right about right here. Then we have 15 and 5.7, so about 15, comma 6, rounded. Then we have 21, 3.6. Four and 3.2. Okay, so do we have 10 right now? It's stopping right now, so that's probably telling me that it got it 1, 2, 3, 4, 5, 6, 7. No, there's 3 more somehow or another that I didn't get. Let's see what the other 3. 1, 2, 3. Looks like we don't have this one right here, so let's see if we can find out what that one is right there. There it is, 14 and negative 7. So that's 8, and then what else do we not have? Looks like we're missing this guy right there. That's 14 and 3.6. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. We're missing one more somehow or another. Oh, this very last one right there. Okay. Yeah, I wish this was a little bit better about just doing it in order. There we go, and it's 23 and negative 2. Sorry about that. The 23 and negative 2. Okay, there we go. We got the residual plot. That's it right there. Okay, let's go on. What is the value of R? What's the value of R squared? Interpret these in context of the problem. All right, so remember how to do that on your calculator. Go to Stat, right here, and we're going to go to Calc. We already have the data in there under Stat. It's already done, right? So we just have to go on to Lin Reg, and we want to choose A plus BX. There we are right there. Okay, and L1, L2. If you want to store your regression equation, you can either just memorize it. If you want to store it in Y sub 1, that's optional. You just go to under VARs right there. Okay, and just put Y1. That's optional. You don't have to do that. All right, no problem. We have it. So we have Y equals 71.35. Okay, well, we can go to 3 decimals. 71.346 minus 1.141. So Y hat equals 71.346 minus right here 1.141x. Sorry. Okay, make sure you put it's right here. So that's the regression equation. I'm sorry, it didn't even ask for that. The next one is going to ask for that. Anyway, at least you know how to do that now. But anyway, they asked for R and R squared. Sorry about that. So R equals negative 8.16. Now let me just do this so I can view it. There we go. I'm going to put this to the side. They didn't actually ask for that. Sorry. So R equals negative 0.816, and R squared equals 0.6660, rounded, right? 0.66599 is 0.6660. All right, cool. So let's do it. Interpret each of these in respect to the problem. Okay, so R gives us the strength and the direction. Okay, so if we interpret R, that's just going to be that right here, we're just going to go and say the linear relationship. And R is just about the linear relationship. So don't reference the line when you're interpreting R. You can get an R even without a line at all. That's just the relationship in general. So we'll just say the linear relationship. Okay, and then between what? And we're talking about anxiety score and exam score. And remember, R is the strength and direction. So the strength point, the negative 0.816, that's close to -1, so it is strong. And the direction is negative. Good. Now we're going to interpret R squared. Okay, R squared, remember, so this is 0.6660, so we're going to say 66.6%, okay? And oh, I'm sorry, go ahead and say actually first. Again, this is an approximation. So we'll say right here, about 66.60% of the variation in the, now the response variable right here, remember, is exam scores, is accounted for by the least squares regression model. Or you can say line, fine, but actually it's accounted for by the least square regression model with, okay, X equals anxiety score. That's it. About 66.60% of the variation in the exam score is accounted for by the least square regression model with X equals anxiety score. All right, we got that there. Okay. Let's go to the next part right here, which is interpreting computer regression output. So this is the whole table stuff, the reading, like this is, you know, they call these the mini tab tables. As you noted already, we will often rely on technology to generate the equation of a least square regression line. You're probably familiar with using your calculator to produce the equation. Make sure you can also interpret computer output to identify the slope and intercept of the regression line as well as other important values such as correlation and the coefficient of termination, which is R squared, right? This right here, remember, is R squared. There is a strong possibility you will need to read computer output for the AP exam. All right, so let's do it. 1, write the equation of a least square regression line. Identify any variables used. Okay, so no problem. So let's do it. So first of all, this right here, remember where it says constant, that is my y-intercept. Because you think about it, y hat equals b sub 0 plus b sub 1 x. B sub 0 is your constant, so that's b sub 0. And we're next to temp right here. Now let's read this. Temperature was measured, a study was performed to determine the effect of temperature on a pond's algae level. Temperature is in degrees Fahrenheit, algae level is measured in parts per million. Consider the output below. So what I'm going to do is I'm just going to write myself a little note that right here, temperature is my explanatory variable. So temperature is like my X right there. And algae right there, I'm going to write, that's my Y. Okay, that is my response variable, is the algae level. They're seeing if temperature affects the algae level. Okay, so right here, this 0.4762 is my B sub 1. Okay, so we got it. Y hat equals B sub 0, which is 42.8477. Plus 0.47620 x. Okay, and now we have to identify these variables. We'll just say where y hat equals, remember that's a prediction, equals the predicted measure of algae level in parts per million. So we just say the predicted algae level in parts per million. And x is going to equal right here the temperature in degrees Fahrenheit. This is the actual temperature. Okay, that's it right there. Secondly, interpret the slope of the least square regression line. All right, what I always think about when we have these like slope questions right here, guys, is just think about what is a slope? Well, just go back to Algebra 1. A slope is, remember, the change in y over the change in x, the difference of the y's over the difference of the x. Okay, so no problem. So let's see, my slope is right here, 0.47620. So I'm going to put that right there, 0.4. Geez, let me go and decrease this a little bit. There we go. 0.47620. You could say 0.4762, that's fine, over 1. Okay, so that means for every increase of 1 for x, there is an increase of 0.4762 for y. Okay, so now we just have to define x and y. X is the temperature, and y is the predicted algae level in parts per million. So here's what we're going to say right here. For every 1 degree Fahrenheit increase in temperature, there is a predicted, remember, we're talking about a least square regression model right here. It's y hat. So there is a predicted increase in algae level of 0.47620 parts per million. Okay, good enough. Identify and interpret the correlation coefficient, that is r squared. Okay, so no problem. Let's go back up. R squared is right there. Sorry, it's not writing for some reason. There we go. Okay, there it is. Don't look at that, remember, and this stuff for right now at least is not useful. Maybe later it will be. All right, so that's r squared equals 0.917. Okay, so let's go and we just identified it. Let's go and interpret it. So we just did that. We're going to say 91.7%, oh, I'm sorry, about 91.7% of the variation in and of y. Now the y in context right here is right here, is the y right here is the algae level, right? So 91.7% of the variation in algae level. Now you don't have to say predicted algae level, because right here, the correlation coefficient measures the it's basically about if the model represents the actual data that's there. So we're going to say about 91%, 91.7% of the variation in algae level is accounted for. by the least square regression line. Okay, with x equals temperature. Okay, and degrees Fahrenheit. That's it right there. 91.7% of the variation in algae level. You could enter and put the units here. Okay, I don't know if that's totally necessary, but if you just want to, you can. All right, that's right here. Identify and interpret the standard deviation of the residuals. Right here, that is S. So we go right back up here to S, and there it is, right there. 0.4224. Okay, so what is a residual? Remember, a residual is the actual minus predicted, right? So right here, you can just go ahead and say right here that your typical don't say this, but what this is saying is that your typical residual, right, is 0.4224. So the typical actual minus predicted algae level is about 0.4224 units. So I'm going to say this, let's say that in context. We'll say the actual algae level typically varies about 0.4224, and we're talking about right here units, from the predicted algae levels. By the least square regression line, LSRL, with the x value equals temperature in degrees Fahrenheit. That's it. Okay. So right here, remember right here, 0.4224 is the residual. That's the actual minus predicted. All right, so the actual algae level typically varies about 0.4224 units from the 0.4224 units from the predicted algae levels by the least square regression line with x equals temperature. All right, that's it, guys. I hope you understand this a little bit better now. Have a good day.